Alright, hello. We're going to be working on finding the slope of a line passing through any given two ordered pairs. So the learning goal for this lesson is being able to find the slope of any line passing through any two ordered pairs. So following with the structured note-taking using the Cornell style, we have our title of slope through two ordered pairs, and we're going to walk through the previous knowledge that must be gained before continuing on with this lesson. In order for you to be successful here, your previous knowledge has to be involved with adding and subtracting positive and negative numbers. If you still have issues with subtracting, especially numbers, you're going to have big issues with finding the slope of a line passing through 2 points. The formula that we'll get into involves subtraction, so make sure you're doing everything you can to become good at adding, subtracting positive and negative numbers. We also need to be good at simplifying fractions and recognizing equivalent fractions. You'll see in the examples that I cover where that comes into play. You have to understand fully how ordered pairs operate, where the x-coordinate comes first, then the y-coordinate comes next. So make sure that you are very comfortable with x first, then y. Every ordered pair is x, y. And then helpful is understanding the relationship between tables and ordered pairs. So make sure that you are really good with that information and do everything you can to make yourself awesome with that stuff so you can avoid a lot of mistakes with the current material. So I'm going to revisit some issues with slope that we covered in the last video, and I'll start by getting us into what is commonly known as the slope formula. But you have to know where the slope formula comes from. If you have any 2 points that are on a coordinate plane, you have 2 sets of ordered pairs. Okay, so we're dealing with 2 points somewhere on a coordinate plane. It's going to be 2 different ordered pairs. An xy coordinate for one point and an xy coordinate for another point. So you have to understand that that's coming from 2 points, 2 ordered pairs. In order to keep those 2 points organized, what we're going to do is label one set of ordered pairs, what we call x1 and y1. Okay, 1 representing the first set of ordered pairs. So x1, y1, and the second set of ordered pairs we will call x2, y2. Again, noting that the x-coordinate comes first in each ordered pair. We're just calling it the first set of ordered pairs, x1, y1, and the second set of ordered pairs, x2, y2. In both sets, the x-coordinate comes first. So we're going to stay organized. We're going to keep ourselves organized by labeling our points. Now, it doesn't matter which is which, okay? It doesn't matter which ordered pair you have. If this ordered pair is x1, y1, this ordered pair is x2, y2. It could be this ordered pair, x1, y1, this ordered pair, x2, y2. It doesn't matter which is which, as long as x1 is with y1 and x2 is with y2. Okay, so the first x-coordinate is with the first y-coordinate. The second x-coordinate is with the second y-coordinate. So it just doesn't matter which one is which. You get to choose by labeling. Now, the way that's related is to the previous lesson. If you recall, when we were counting slope, when we were counting rise over run, if you recall, it didn't matter if we counted up from one point to the next or if we counted down from one point to the next. We still had the same slope. So the same is true with labeling your points, x1, y1, x2, y2. It doesn't matter which is which as long as you stay consistent with your labeling. So going back to the concept of slope, remember slope was rise over run, which was the change in the y-coordinate over the change in the x-coordinate. Remember, we used the Greek letter delta to represent change. So it's the change in the y over the change in the x. And this concept of slope, which still remains the same, leads us to the slope formula. So the slope formula is m is equal to y2 minus y1 over x2 minus x1. Okay, it's equal to the change in the y coordinate over the change in the x coordinate, the rise over run. So the first point of confusion is, well, what is m for? Now here's the little blurb. I've done a little bit of research. We use m to represent slope. M is the letter for slope. Where does that come from? It's highly debated. We don't know where. It's an unknown reason. Some of the best guesses are that the n stands for what's called modulus of slope. Some countries actually use the letter A in alphabetical order, or K for a constant. Some countries use S for slope, but here in the United States we use the letter M. And I'll use it later to represent the word move when we get into graphing, so using a different method. Just know that the lowercase letter m is to represent slope, widely used across the world, even in the countries that use different letters. So, of course, m means slope. Don't get too confused with that. Just m for us means slope, and later on I'll use it to use the word move. So, we're focusing on the formula, the change in y over the change in x, y2 minus y1 over x2 minus x1. And we can use any two ordered pairs in that formula to find the slope of the line passing through those ordered pairs. So I'll begin by demonstrating a few examples. By the end of this, you will be very comfortable finding slope from any two ordered pairs. So in the first example, I'm going to ask you to find the slope of the line passing through the ordered pairs 3, 2, and negative 2, 7. So we're going to find the slope of the line passing through the ordered pairs 3, 2, and negative 7. Everything in math is a picture, so right now what you can do is visualize where this point would be, 3, 2, and where this point would be, negative 2, 7. So there's 2 points in a line. We can find the slope using the slope formula. Now the first thing we have to do is to be organized. Okay, we have to organize ourselves. Label your points, x1, y1, x2, y2. And as I said in the notes, it doesn't matter if we call this x1, y1, and this x2, y2, or this x1, y1, or this x2, y2. So it doesn't matter which one as long as you're consistent. So I will label this one x1, y1, and I will label the second one x2, y2. Okay, so the first thing we're going to do is label our points. The second thing we're going to do is recall the slope formula that I gave in the notes. Remember, slope is the change in y over the change in x. y2 minus y1 over x2 minus x1. The change in y over the change in x. And now all we have to do is substitute our values from where we were organized. y2 minus y1. Okay, so we're going to substitute values. And then x2 minus x1. So all we're going to do is substitute values. So remembering that slope is y2, which was blue. The minus sign comes from the formula. This minus sign is in the formula, so it stays there. The minus sign stays there. And then y1, which I labeled in red, so I'll use the color red for that. And that is our change in y. And now we substitute our change in x. x2 was negative 2. The minus sign comes from the formula. x1 was in red, is 3. And so we have our values that we've substituted into the formula. So we had our slope formula, we switched out our values, we get to here. Now comes the part where I talked about previous knowledge. It's important for us to know how to subtract correctly. So we subtract our y values at the top. 7 minus 2 is 5. And we subtract our x values at the bottom. And negative 2 minus 3 is not negative 1, it is negative 5. And so we have our slope as 5 over negative 5. And all we do now is simplify that fraction. Again, the other piece of previous knowledge, simplifying fractions. We're going to simplify that fraction if possible. Can we simplify 5 over negative 5? Of course we can. That turns out to be -1. So the slope of the line passing through these 2 points is -1. That means, going back to the definition of slope in our previous lesson, the slope of -1, the y value is decreasing 1 unit for every 1 unit that the graph goes along the x value, or the x-axis. So the slope is -1. It's decreasing 1 y per x unit. And that's how we figure slope. Now, we can also use tables to find the slope. So I can create a table of values, and we can find the slope of the line represented by this table of values. So if we have all the x coordinates, or all the x values are -24, -20, 0, 4, and 16, all the y values being -7, -6, -1, 0, and 3, if we have a table of values represented by those x's and y's, we can find the slope of the line represented by this table. Now this is a common standardized test question. We'll give you a table of values and we'll say, find the slope of the line represented by this set of data. With this, you have so many different options to do this correctly, it's up to you. The way you work it is that you pick any 2 xy pairs. You can pick the xy pair of -24 and -7. That's an x coordinate and a y coordinate. You can pick the xy pair of -20 and -6, 0, -1, 4, 0, or 16, 3. All of those are ordered pairs. All you have to do to figure slope is to pick any 2. Okay, so we just need to pick any 2 of these. My personal recommendation is to pick anything with 0. Remember I talked about how much fun 0 is to work with? If it were me, I would pick these 2 ordered pairs. But since most of you watching this are not me, I'm going to choose some pretty challenging ordered pairs from this table to use. So I'm going to choose the ordered pair -20, -6, and 16, 3. I'm going to use these 2 ordered pairs. So I'm going to use -20, -6, and 16, 3 as my ordered pairs. I'm just picking any 2 from this table to use with the slope formula. Once we have our 2 ordered pairs, again, the important piece is to label your points correctly. Label your coordinates. You have x1, y1, and x2, y2. So you've labeled your ordered pairs. Now you recall the slope formula. The slope formula is the change in y over the change in x. y2 minus y1 over x2 minus x1. Now pause here because a lot of students ask, can I have the formula written y1 minus y2 over x1 minus x2? My answer is, of course, because it doesn't matter which one you label. For some reason we like to put 2 minus 1. I guess we like to have even our organizational numbers to be positive, so it doesn't matter as long as you are lined up. Your x-coordinate with your y-coordinate, your x-coordinate with your y-coordinate. So now that we've recalled the formula, we are ready to substitute our values. Slope is y2, which in this case is 3. The minus sign comes from the formula. This minus sign comes from the formula. y1. What is y1? It's -6. So what do I already have the negative here, right? But that comes from the formula. This minus sign comes from the formula. I haven't put the negative of -6 in until just now. Okay, so you have to understand where all these signs are coming from. So I have the y2 minus comes from the formula. The y1 has a negative in it, so I repeat that negative. And you'll see how that works in a second, remembering that we need to be good with subtracting numbers. So the same thing with the x's. My x2 is 16. The minus sign comes from the formula. And the x1, which was -20. This minus sign is from the formula. This is from the negative 20. Please do not get confused on that. It's going to mess everything up. Once we have our values substituted to slope formula, we can now subtract. Okay, so let's subtract. Slope is 3 minus negative 6 is not negative 3. 3 minus negative 6 is positive 9. You have to be good at subtracting. 16 minus negative 20 is not negative 4. It is positive 36. You have to know how to subtract. So yes, both of these turn out to be positive. Finally, we are able to simplify our fractions. Remember that piece of knowledge for prior knowledge. We need to be able to simplify our fractions. So the slope is equal to 9 over 36. Can I simplify that fraction? Yes. What number can be divided on both the top and the bottom? 9. 9 can be divided on the top and the bottom, which leaves us with 1 over 4. That is our simplified slope, 1 over 4. So our slope of the line in that table, the slope is 1/4, which means that the y coordinate, the y value, increases 1 unit. The y value increases 1 unit for every 4 units increased on the x. Okay, so the y value increases 1 unit for every 4 units on the x. And that is our rate of change, or slope. So from the table of values, we can use the same formula. You have to be careful, though. Sometimes questions will ask about tables. Sometimes the questions will be, if these were all different months, it'll say, find the rate of change from January to February. If this is January, this is February. You have to use these two ordered pairs. Find the rate of change from blue to yellow, depending on what's happening. If this is blue, this is yellow, you have to use those two ordered pairs. So using tables depends on your ability to read the question carefully. So just be careful, you may be encountering some of those. Let me do a couple of more examples to illustrate some fun points, some shortcuts that can only be used in special circumstances. So I'm going to give you 2 more ordered pairs, and we're going to find the slope of the line that passes through them. So in the first example, we have the ordered pairs -3, 6 and -8, 6. So we have our 2 ordered pairs. Find the slope of the line passing through it. So just as usual, we label our points. Make sure you label them correctly. x1, y1, and x2, y2. Recall your slope formula correctly. The change in y over the change in x. Substitute your values correctly. Slope is equal to y2 in this case is 6. The minus sign comes from the formula. y1 in this case is also 6 over x2 in this case is -8. The minus sign comes from the formula. x1 is -3. Now what we do is subtract correctly. 6 minus 6 is 0. On the bottom we have -8 minus -3. It is not -11. If you're subtracting correctly, you will get -5. So the slope is 0 over -5. Can we simplify this fraction? Yes, we can. Punch this into your calculator. 0 divided by -5. You will end up with 0. Do you remember where we encounter a slope of 0 from the previous lesson? We encounter a slope of 0 for a horizontal line. So the slope of 0 is for horizontal lines. There is a shortcut for this. What do these 2 ordered pairs have in common? If you look at the ordered pairs, you will see that the y coordinates are the same. Picturing everything in math is a picture, picturing the points. -3, 6, and -8, 6. That y value of 6 is the same, making a horizontal line. Automatically, the slope is 0. So the shortcut is, if you see that you have the same y coordinate, you know the slope is 0. That is a shortcut. Let's do another example. Let's say we have the ordered pairs, -4, -8, -4, +8. Find the slope of the line going through those two ordered pairs. We label our points x1, y1, and x2, y2. We recall the slope formula. It is the change in y over the change in x. And we substitute our values. Slope is y2, which is 8, the minus from the formula, y1, which is -8, over x2, which is -4, the minus from the formula, and then x1, which is also -4. So here's where you have to be careful subtracting. Make sure you remember how to subtract. In the numerator, 8 minus -8 is not 0. It is +16. In the denominator, -4 minus -4 is not -8. Minus a negative becomes a plus. That becomes 0. So, can we simplify this fraction, 16 over 0? Of course we can. Punch this into your calculator. 16 divided by 0. And what happens? You get that E in your calculator. E for error. And error means this is undefined. You cannot divide by 0. That is an undefined value. So yes, you can simplify it. Remember, 0 on the top was 0. 0 on the bottom is undefined. What do we know about undefined slope? From the previous lesson, vertical line. So undefined slope, vertical line. Let's go back to our ordered pairs. What do these two ordered pairs have in common? -4 in the x. -4 in the x. Visualize the ordered pairs. -4, -8. -4, +8. Vertical line. Undefined slope. Shortcut. If you see that the two ordered pairs have the same x coordinate, you know it is a vertical line, undefined slope. So that is how we use the slope formula, and that is also how we can get with some shortcuts for vertical and horizontal lines. So I hope you learned some from this lesson. I will see you next time.